Let's look at problem 1839, longest substring of all vowels in order. So we are going to write a solution based on the standard two-pointer sliding window method. So actually we practiced a number of similar problems following the same idea. So here we will first look at the statement of the problem. Then we will analyze how to check effectively a substring is beautiful. And then we look at the code, and after the code we test several examples and comment again about the way we check the substring being beautiful. So now let's look at the statement of the problem. First, it gives us the definition for a string being beautiful. So here a string is beautiful if it satisfies the following two conditions. The first condition is that all the vowels must appear in the substring. And the second one is that all the vowels must appear in alphabetical order. So next, the problem lists several beautiful strings, like this one and this one, and also several substrings which are not beautiful. For example, this one, due to the order, is not beautiful, and this one, due to the fact that some of the vowels does not appear in the string. So the problem requires us to return the length of the longest beautiful substring in the given word. So if no such substring exists, we return 0. So again, here we are considering substring rather than subsequence. So now let's look at the constraint in this problem. So here the word is not empty, and the length can be up to order 10 to the power 5th. In other words, we cannot solve this problem effectively using brute force. So the second constraint is that the word consists of only vowel letters. So now let's state the method and look at the example. So first, the method we're going to use is a standard two-pointer sliding window method. And the condition to check is that the substring is being beautiful. The main idea is that for each index, CL, so we try to find the longest beautiful substring starting from this index, if there exists such substring. So with that said, let's look at the examples. For example, here in example 1, we have a beautiful string, so which start at A and ending at U. So all the letters appear in order. So the length is 13. And example 2, we have one beautiful substring, which is A starting from A and ending at U, and all the vowels appear in order. So in example 3, we have a word which is A, so the length is 0, because for a beautiful string being beautiful, the length is at least 5. So with that said, let's run the two-pointer sliding window method. So first, let's make some preparations. So we can get the length of the word, so just for convenience, and also we set the length to be 0. This is the variable we are going to return. So now in order to check effectively the order, so that's also the key. Let me write here. So the key is how to effectively check that a string is beautiful. So for this, we are going to introduce a order and check the beginning and end for a substring. So let's first introduce the order. So So we have 5 vowels. If we this is the one, let's copy it here. Let's introduce it as aux just for convenience of writing. So we introduce the order. So let's see, so character and index. For index and character in enumerate aux. So this gives us the correct order. So the smaller the character with smaller values should appear before the character with the larger value. So now with that said, let's run the standard while loop, that is a sliding window step. So we initialize the 2 pointers by 0 and 0, and then we enter the while loop while L is less than N. So the first is that we want to find the index corresponding to A. Right? So on or after the previous state of L. So for this, we check if word L, if it's not A, so we need to increment this L and continue the process. So after this, we will get a state of L corresponding to letter A. So if it has, so then we try to expand the window. So we first set R equals L plus 1 because the end index should be greater than L. So now we go to the critical condition for checking the substring to be beautiful. So here the condition is necessary. So first we need this one, R is less than N, and we check the order corresponding to word R and word R minus 1. So let's write like this, R minus 1 and R. So the corresponding order is the order this guy, and order this guy. So the character corresponding to index R and should either have the same order as the previous letter. This is the case, or it one larger than the previous one. So let's copy this one. Let's copy this one and write like this. So we add one here. So also we add parentheses here in order to make sure the logical order is correct. So once we have this, so we can update the pointer by 1. So once we get out of this loop, so in order for the substring to be beautiful, we need to check another condition. That is, if it ended at U, right? So here we make sure it starts at A. Then here we make sure it ends at U, and here ensures the order relation. Then if this were the case, then we find one substring which starts from L and ending at R minus 1. So in this case, so we can update the length. Length is maximum of length, and L R minus 1 minus L plus 1. And this is the length of the corresponding beautiful string. In other words, R minus L. Then actually here we can print out the things to check our solution. L R plus R plus 1. here not r plus 1 but r. So then with that said, once we exit, so we can reset the left pointer L to be r, the current r. Notice again, so here is r because the potential beautiful substring starts from L and ending at r-1. So after this, we are ready to print out the result or return this one. So we return the length. So now I think let's check several examples. So this is for example 1. So we know the beautiful string is this guy, and it starts at index 7 and ending at before index 20, right? So that's so here if we like, we can actually print r-1. So let's check another one. So the second example. So for this one, so we have our beautiful string is like this. The length is 5 and the starting index is 15 and it ends before 20. So let's do another check, that is this one, A. So in this case, we will have return 0 because there are no valid beautiful substring. So up to now, we are good to go. Let's check the generic case. Click submit. Yeah, it passes the generic case. That's it. Thank you.